In this video, we first look at installing the libraries we'll be using. The 4 libraries we're going to talk about in this video are NumPy for numerical array processing, Pandas for data manipulation, Sklearn for the machine learning algorithms, and Seaborn for plotting. You can install these libraries with Anaconda. I personally prefer just using pip to control what gets installed in what version. The first thing you'll want to do is upgrade your pip. If you have Python and Python 3 installed on your computer, you'll want to use the second line, Python 3-m pip install -- upgrade pip. This box gives several examples of using pip. Pip, or remember it may be pip 3 on your system. Install X, where X is whatever package you want. You can specify a version or that you want newer than or equal to that version, and you can upgrade existing packages. And you can also install and check your versions here. First, I'm going to import it as NP and check my version. NumPy is a library for efficient scientific computing. The key data structure in NumPy is the array, which is a multidimensional object where elements have to be of the same type. NumPy arrays are more efficient in terms of storage and computation than native Python lists. The .array method will create an array from a list. Notice you can access it with the same syntax you would use to access list elements. The rank of an array is the number of dimensions, called axes, and the shape is specified by a tuple of integers of the length of each dimension. So for a one-dimensional array, we have the length of that array and then comma, because it is a tuple. This next example constructs a 2D array from a list within lists, and notice its shape is 2 by 3. Its row column. We can also change the shape with reshape. This first line of code creates a 1D array for the numbers 0 through 9, and we print that out here. And then we reshape it into a 5 by 2 array, which is printed out here. We can initialize an array with whatever we want. And there's also a convenience function here to create a zero-filled array of the shape that we wish. One of the useful things about NumPy is the built-in math functions. We have methods like sum, mean, and min, and so forth, and also constants like pi and e. For these functions, you can apply them to the entire array, or you can specify an axis on which to apply it. Here we see a Boolean selection of elements of an array. We can sort an array. Other useful features in NumPy are that it supports vector, dot operations, and matrix operations. And also we can use it to generate arrays of random numbers. In this notebook, I've shown the functionality of NumPy that we're most likely to use in machine learning. There's obviously a lot more to NumPy. I have a link here to a fuller tutorial and the complete documentation. The Pandas library is a powerful data analysis toolkit for structured data. A Pandas series is a one-dimensional data object. A Pandas data frame handles two-dimensional data. In this first example, we see that we've read in a CSV file, converted it to a data frame, and used the head method to print out the first 5 rows. This code shows a couple of ways to index elements. We can put the name of a column or use the dot notation. There are also LOC and ILOC accessors. Both specify indices in row column order. LOC uses labels, ILOC uses index positions. For example, df.loc from row 1 extracts the age value, and here from 2 rows extracts 2 columns. Doing the same exact thing with ILOC, we're just using the index positions. We can extract a new data frame from an existing one using the double bracket notation. Here we're extracting a data frame with just 2 columns, sex and age. We can slice data frames, selecting the column and then a number of rows. When we extract just one column, that's generally going to be a Pandas series, not a Panda data frame. In order to force this to be a data frame, we need to put double brackets around it. We can select rows by index, by a Boolean condition, a random sample of a fraction of the observations, a random sample with a specified number to retrieve. We're going to be using Pandas for data manipulation, as I'll show later in this video. I've tried to show the most commonly used functionality, and as always, there's much more documentation available online. The Sklearn project began in 2007 and had its first public release in 2010. Sklearn is an open source project supported by an international team of developers, and they release new versions about every 3 months. The home page has links to some great tutorials. In this video, I just want to show a quick example to get a feel for the Sklearn syntax. The example in this notebook uses a built-in data set, the iris data set. The built-in data sets already have the data and the target separated. The type of an Sklearn built-in data set is called a bunch. It's really just a dictionary with key value pairs. These are the things that we could access: data, target names, and so forth. If we look at the type of data and target, we see that they're both NumPy arrays. For the machine learning, we'll have X be our predictors and Y our target. And we could convert that to a data frame with this Pandas function here. All of the machine learning algorithms in Sklearn are implemented as Python classes. We see here from Sklearn neighbors, we're importing the class kNeighbors classifier. And then we create an object of that class. The object will have built-in methods to fit the data, to train the model using the data and the targets. Sklearn also has a lot of useful functionality for machine learning, such as train, test, split functions. Here we're sending it the X and Y, telling it how much we want in the test size, a random state, and whether or not we want it stratified by class. So given this KNN object, we can fit, predict, and score, all using that object. The nice thing about Sklearn is the uniformity of the syntax. So once you learn how to do one algorithm, it's a simple matter to do the other algorithms as well. There are many libraries for data visualization in Python. I like Seaborn because you can get good-looking graphs with a minimal amount of code. And I have a link to documentation here which gives many example graphs. I'm going to import Pandas, Sklearn, and Seaborn. Seaborn is often imported as SNS, and according to the legend, the reason is that the author was perhaps obsessed with Rob Lowe's character on West Wing that had the initials SNS. So I've never watched the West Wing, I just import it with 2 letters here like everything else. So I'm loading a data set so we have something here to plot and converting it to a data frame. This is an example of plotting one quantitative array using the displot. This curve is implemented with KDE true and the rug showing the individual data points with rug equals true. And you can see just using the default settings and default colors, it looks pretty good. 2 quantitative arrays can be plotted with the relation plot. You specify X and Y and the data. In this plot, I'm specifying that the color of the points be the species and the style be the species as well. Plotting categorical data with cat plot, we see that all 3 species have the same number of observations. Here's a box plot, plotting species on the x-axis and petal width on the y-axis. And you can see there's very good separations between the species for petal width. By the way, if you want to know the type of any column in a data frame, you can say df.dtypes and it will print out every column and their type. In this notebook, I'll show the most common types of data cleaning we'll need to do before the machine learning, such as reading in CSV files, getting rid of columns, dealing with NAs, checking and changing data types, and encoding categorical data. Here I'm importing a CSV file, which will be a data frame, printing out the first 3 rows as well as its dimensions. I can get rid of columns with the drop method, so here I want to get rid of columns row and pedigree, and we see that they're gone. I can sum the number of NAs by column, and we see that triceps and insulin have quite a few. Here I'm going to use NumPy to help me fill triceps and insulin missing values with the average. So first I calculate the average, the mean, and then fill NA with that mean in place, meaning it will update the data frame in place. And here we do the same thing with insulin. Checking for more NAs, we see that there are just a few left. To get rid of those remaining NAs, we're just going to drop NA, which will drop all rows that have any NA in any column. Our new shape is 724 by 8. Checking our types, we see that they're numeric. Diabetes was read in as yes, no. That is a string. Strings will always appear as objects. We need for diabetes to be a categorical data type. So I'm going to copy this to a new data frame and convert .diabetes, convert that one column as type category. And now we see it's categorical. This is roughly equivalent to the factor in R. When we do that, we see that it still displays as positive or negative, but internally it's stored as a category. Another way to handle categorical data is to use numeric factor codes. So I'm making yet another copy of the data frame. This time I'm changing diabetes into type category.cat codes. And now we'll see that diabetes is actually an integer, and we see a binary encoding here. So those are 2 quite different ways to handle categorical data. Most Sklearn algorithms can handle either one. The numeric encoding is more commonly used. Some algorithms also accept one-hot encoding. So just to create an example, I'm using a subset of the diabetes data frame, just showing pregnancies less than 5. I'm going to use the built-in get dummies on the pregnant column, putting that in a variable I'm calling OHE for one-hot encoding, and we see the one-hot encoding here is very much like dummy variables in R. Now I have to glue this together, concatenate it with the other columns. So I'm going to use it in a built-in concatenate. I'm putting the one-hot encoding first, and then the rest of the columns, except for pregnant. We're not going to use one-hot encoding very often, but I wanted to give an example just in case you need to use it. Let's consider an example of how we might detect outliers in the data. So here when I say dfmin, for every column it will give me minimum values, max will give me maximum values. Here I want to sort my values by triceps and print the first 10. And we see that it's ascending order by default. And here I'm using a plot. I'm plotting diabetes on the x-axis and triceps on the y-axis as a means of possibly identifying outliers. In these notebooks that I'm covering in this video, I'm showing the most common uses of NumPy, Pandas, Seaborn, as well as some data cleaning practices. The amount of material may be a little bit overwhelming. Don't expect to have this memorized. You have the notebooks for reference when you need it. And by the time we go over many more examples, this will become second nature.